Hello and welcome back to compiler programming. In this video, I thought I'd start tackling structs. Obviously, we will not be able to do everything today, but I want to have the basics of having fields and being able to access and modify those fields done today. So let's, as always, start with a test and see what is the API that we wanted to have. Should support structs. Okay. Now we probably want to modify descriptors somehow. We will need to have a special descriptor type that is struct. Okay. And it's very likely we also need something like struct field, but I'm not sure about it. So let's start with just saying descriptor type struct and try to figure out what is going to be in there. Descriptor struct. We don't really need to have one of the interesting things will be to figure out how we're gonna deal with names of the fields. Like ideally we should not need to do any kind of string comparisons when accessing those fields, even in the current DSL state. So let's think about this. Would be nice if fields just had sort of offset directly in them so that we can use this for the calculations. And just to kind of give a bit of a background information, the way this all works is when you define a struct and you define a field. Let's take something simpler, like, oh, this is fine. So what happens is this just calculates the total size that's necessary to store both of these fields, and then remembers at which offsets these fields are. So this is basically only a byte, but I'm not sure if the resulting struct is actually a byte or longer. Probably it is due to alignment, but I'm not sure. And here, so for example, this would be at offset 0, and this would be at some offset that is after register, which is either it's 1 byte, or if it is aligned, then probably at 8 byte. But I'm not so certain. We can try to figure out what are the rules for the alignment later for C, because obviously we will need to support interpretation between C and this language. But for now, let's just ignore the alignment and always create what is probably called the packed structs. So when the fields are always next to each other, and this is something that we also have to support anyway, because like packed structs are a thing and they're useful in certain situations. So let's just start with the simpler version. Okay, so descriptor struct. We will have probably same as with the function. We'll have field count, and for the value, for the field list, it's actually interesting what we're gonna put in there. I guess we add another struct, type def struct descriptor struct field, and this is what we're gonna use for the field list. Now field is gonna be what? It's gonna point to a descriptor for what is stored in that field, right? So if you look here, field basically consists of the name, but again, we will not actually be encoding names, I think. And also the type that is, or descriptor in our terminology of what is stored in that field. And one thing that is not visible, but is also part of the field descriptor, is the offset from the start of the struct. So we can also do that. And the reason I'm doing this as S32 is because we're going to be putting this into displacement when encoding, and honestly, again, we will not support structs larger than 2 gigabytes anyway, so it's perfectly fine to make our life easier and just say that this is going to be S32. Good, so we have this setup. This should compile, and it does. Now we are ready to try to make the first function and the first usage of the structs. Maybe what we can do is to say that we will create a kind of a size struct. So again, in C terminology, this would be something like struct S32 width, S32 height, right? So something like this. Struct size. This is what we will try to do, and maybe we have a function that just returns us the area of this struct. Okay. Let's see. The way we do this is we say we have a descriptor and size struct descriptor. Type is going to be struct, and we did not add this, but we should. This should actually go here. That our struct is part of this union. Okay, that's good. And we probably cannot actually name it struct because it's a keyword, but let's see if C complains. Yeah. So we cannot actually call it struct. What shall we call it? It's an interesting question. I guess it's going to be called struct underscore, which is a bit yucky, but honestly right now I'm not sure what would be the best way to deal with this. It's called struct underscore, and it needs to have 2 fields. So let's create those 2 fields. I say descriptor struct what? Struct field width field is now we don't need this. We say type is, we don't even need to have a type. Honestly, it might be better if this is not a descriptor. Maybe it is. Not sure. Okay, it's fine. Let's do it like this. And we need to have, did I call it descriptor or not? Yeah. Descriptor is descriptor S32, right? And then offset is 0. For now, I will just do the layouting of this manually to check that everything works and we know how it's supposed to work. And obviously later on we will create a function that will do that layouting for us. And it's going to be very similar to how we deal with function arguments. So something like this, we will just store a builder and it will have a struct builder that does this calculation, which is going to be pretty easy and nice to use. Okay, so we have a width field. Now we want to have height field, and actually this is not how we want to do this because we need an array, right? So we should say struct field fields2 and do this stuff. It's gonna be like this. Yep. Actually, wrong place. I needed to copy this thing. Okay. Size of 32. Good. And we can extract them for nicer naming because we will need to access them later on. So just say fields, and this is fields. Let's do it in a more expressive way, I guess. Good. Now we say that our fields list is fields, and then that the field count is 2. Okay, now it complains that all of these things are unused, which is fine. We can deal with that. Good. So we have the struct. Now we need to do something with it. That means we need a function, and we can do that easily. Now, here comes the tricky part. When of passing things by value versus passing things by pointer. And I will not do the value version right now because that will be quite a long side gig. So right now let's focus on the pointer version, which is honestly more common anyway when interacting with APIs, and this is the part that I want to get to, where we can call, for example, Windows APIs and try to do funky stuff with them. So this means we will need to have size struct pointer descriptor as well, which is going to be similar to this, right? And it's good. So we have this, we have a function that gets our struct as the first, or pointer to our struct as the first argument, and then it will do something to it. But for now, we can just say, what shall we say? Let's just make it return the first, the width field, or maybe the height field is actually a bit more interesting. So it will return some value, and value is going to be the width or height value. And what is height value? Again, we do everything through the stack. So we do reserve stack of builder, and we need to say descriptor. So we say that descriptor is going to be height field descriptor, right? Okay. Next thing would be to do a move. We take and this is a tricky part where we will need to construct an operand out of this field, out of the array value or out of a struct value, or more precisely pointer to a struct, and this descriptor. Right now, again, let's just follow the steps manually and see how can we later on maybe automate this stuff and make it nice to use. So actually we might not need this. Let's not do this temporary value for now. Instead we say again, height value is what? So we need somehow figure out a way to encode this field. And for descriptor, this is pretty easy. We just copy the field descriptor. But for operand, it's a bit more involved than that. And it is again going to be this memory indirect stuff. Because when we are trying to access a field, we're just saying, okay, this is a base pointer where struct starts, and then we just adding an offset of the field to that base pointer, and this is going to be the right memory where the field is located. Okay, so let's do that. Byte size is, we can do descriptor byte size of this, and we need to have a register. Right now I will cheat and just do, so I'll add a fix me here, but to make first progress I will just say arg0 operand register index. This should be fine because I know that it's going to be in RCX, but better to do this through temporary value like we were doing there, but a bit later. The main point is now actually quite easy because I have this displacement field in the indirect memory operand, and this is exactly what we're going to use for this offset. Okay, and I will remove this move for now and say that we return height value. Now we can do value as function, and I want to copy probably this version to us, and type will be quite interesting. So we need to now have a C struct that we can use for this argument, and I'm not entirely sure if we would be able to easily do that. I guess we can probably use void pointer. So say like void p to s32. Yeah, that's very, very unsafe, but this is fine for now. And we will call this get height. Okay, s32 result. And now we need our struct. I'm not sure if I will be able to define it in line, but let's try. Struct s32 width s32 height. And again, I'm not sure it's going to be how packed it's going to be, but this is something we'll figure out. 32 width is 32 height. And then size is 10 by 42. So let's see how badly this blows up. The first thing is we need to have is this stuff. So we want to have void p to s32, and this is going to be now void star. That's good. Compatible types. Yeah, we definitely don't have array pointer descriptor. Instead of its size struct pointer descriptor. Still no dice. What else is wrong? Missing semicolon before function return. Oh yes. Yes, indeed it is. We are not using this. This is fine. We can remove this. Okay. So let's see how spectacularly this blows up, and then we will start to work. Apparently, it all works from the first try. Still, let's look at the disassembly, because I'm not exactly certain this is correct anyway. And also it's just a nice way to see what the way this displacement stuff works. Okay, are you done? We mark a breakpoint here. Let's look at the assembly. Think. Okay, yeah, and this is exactly what we wanted. So RCX is a pointer to struct. We go over here and we try to say size of size, identify size. Yeah, because we are in different function. Let me start again. Okay, so it looks like when I do this kind of stuff, it actually ends up being the size of So 8, there is no padding here. I honestly have no idea what are the rules for struct paddings. It's something I need to brush up on. But for now, this means that our code is actually correct, and the offsets that we have here match the offsets that we get here. And it looks like for ease of interoperability, we will have to add a parser for the struct type definitions in the same way that we started working on the parser for function type definitions, because otherwise it will be really, really annoying to constantly type those into ourselves, as they are quite large, as you can see. Anyhow, there is still a little bit of cleanup to do before we can fully say that this is working as expected. In particular, we need to store our argument in a temporary value and then load it in, or we can actually load it directly in ArrayX. We don't need the temporary value here, to be honest. But let's do that. So we say we want to move from arg0 operand to to ArrayX. And then here we can say ArrayX register index, and that takes care of the fact that we are technically not guaranteed that this value is going to be inside the register, because I mean, since we expect it to be a pointer, it is more or less guaranteed, but it's still more robust to do it this way, to say that whenever we want to access a field of a struct, this is our code that we'll be doing, and this means we will be able to extract it into a separate function later on. Okay, let's check if this builds and check if this is working as well. And it does. So just as to have something more complicated, let's, as I mentioned, let's try to maybe write a function that will multiply these two fields. What is it gonna look like? Yeah, so we will need a temporary value, obviously. We'll need to store these two fields, and this is gonna be high field value. We reserve the stack. The amount that we reserve is gonna be how much is the descriptor of this, and then we move from the height value to there. Okay, that's fine. Now, it's a bit unfortunate that we have multiple things that are called height field value, height field descriptor, height field, just height field. But that is fine. So we store this as a temporary, but maybe we actually don't need to, because the temporary stuff will be taken care of by the multiplication code anyway. So we can just do the second one, or maybe rather the first one. So now we will need the descriptor of the width field. That's good. width field, width field, width field. So now we have these two values for this stuff, and we can do, hopefully at least, we can do multiply of this stuff. So we need to pass on a builder, and then we need to say a width value, height value, right? Okay, now it's called area, and we say area of size, and it is going to be 420. Multiply differs actual parameter. I think we have to pass it by pointer, and now it's good. Something did not work out as we wanted to, so let's consider what that is. I guess we need to store those things in temporary values somewhere, but I think it would be a better place to do it in multiply, because this is a more the function that we're going to be reusing more. But let's first figure out which one is actually failing, like which field, which encoding is failing. Okay, let's start. He did not find acceptable encoding, and this, I guess it's this stuff. So it cannot do B operand. What is B operand? B operand is memory indirect. Okay. So oh yeah, this is actually, whoa, I hit the Windows feature. We need to have a different encoding for this. We need to do this one, right? Where we use register memory as the stuff. So yeah, this is definitely something to fix in here. Okay. Maybe we can also at the same time deal with this immediate 64 thing by saying that we're just gonna store the operand in the value second operand, or second. We already have B temp. No, B temp. And then we move. Yeah, that sounds good. Like so, right? That means that if we have immediate 64, it also should work fine, I believe. Actually, maybe not, because it wants a register in there. So like ideally we need to move it through ArrayX, so we still have to leave this comment there. But for our purposes, we can probably now say ArrayX and btemp operand. It's still not gonna work. Still need to add this encoding, probably. Let's search for imul. Yeah, it doesn't have the encoding that we want, so we need to add that one. And the encoding that we want is this one. So it's 0f, what's it, 0f-af. And then it's like so. Oh, that's actually also quite dangerous. It should be like this. Okay. Let's see if this is better. It still did not find the acceptable encoding. Well, that's unfortunate. Is it still the same place though? Is in our new function. That's good. That means that the old one actually did work. And does it mean it did not find move to this stuff? Wait. Let's do this stuff. So we are in multiply. Yeah, it did not find the move, which actually makes a lot of sense because you cannot really move from memory to memory. Instead, it needs to be inside a register. And that means that we need to shuffle some things around. So the A apparent should go into array X here, and here we need to do two-step move. So we first move our B operand to array X, and then we move it from array X to the temporary value. Right. And now it does deal with immediate 64 because it's safe to move to a register. Okay, I mean, in reality, we only need to do this stuff if the incoming value is not already a register or memory. So only if this is immediate, I guess. I guess so. But maybe that's a comment we can add it to do. Make the move only for immediate value. Okay. We also, for example, could stash it in our CX register and store that. Like there are various options that we can think of here. For now, I just want to make this work. And it is probably better than it was before, but now it just hangs, which is not great. So let's see what is happening. we can correctly encode the function, but when we try to run it, something goes terribly wrong. Let's look at the disassembly of this. We move to ArrayX. This is kind of strange. Why are we moving RCX to ArrayX? Oh, this is not good at all. Yeah, this is not what we want. So what's going on is, if we look, let me bookmark this and then go down and look at this stuff, which I also bookmark. So if you look at what we are doing, we are moving the argument to ArrayX, but then we are also using ArrayX in multiply, and it obviously messes up everything that we wanted to do. How shall we deal with this stuff? So there are a couple of ways we can do it. And mostly it all revolves around adding a new instruction that is the way we want to do it. Although, no, not really. So there is this instruction that we will need to implement at some point anyway, which is called load effective address, which takes a memory location and loads the address of that memory location into a register. But now that I'm thinking about it, it might not be exactly what we want, because we still need to somehow keep this stuff in a different register. So I guess, I mean, we can copy the value out of each of these values and then do the multiply on them. Well, I guess this is what we're going to be doing. So we say value temp. Will this help us? Yes, it will. Because our problem right now is this ArrayX register. And in reality, we can just, for example, say, do this, right? This is perfectly safe to do according to the setup of the function of the calling conventions, right? Because ArrayX, RCX, R8, and R9 are reserved for arguments of the functions, and even if the function does not actually use those registers that does not have those arguments. So like even if function does not accept any arguments, it's still considered that the function might use those registers, and the function that calls us will have to kind of consider these things as being volatile and have garbage after the call. So like this version should work, I believe, and it's technically safe, but it would be a good idea to consider how to do it in a more precise way. Yeah, this works. So this is something I should think over, I guess, offline, and figure out what is going to be the approach that we're going to take here. Maybe I will just bite the bullet and start working on tracking like which registers are available and allowing us to use those registers, or maybe I will make it easier to store values on the stack. Either way, it's gonna be fine. So I will just add a to-do here and say, figure out how to deal with temporary values. But today wasn't about that. It was about making field access work. Let's check again how our function looks like. We can even move our stuff here. We go to Disassembly and look at marvel at our function. So it does absolutely useless move, but that's fine. And now it loads a value into arrayx and then moves it out to some location on the stack, which actually is probably not the right way to do it because we are using the wrong size of the register here. Yeah, this is actually might mess up the stack in certain situations, so this is also wrong. But this, I also noticed this before, and we will need to do a single pass over the whole compiler right now that will exchange this kind of hard-coded RCX and arrayx registers and whatnot with a helper function that will look something like get sized register for descriptor, and we will pass in, for example, the descriptor over arg0, and it will give us RCX or EAX or AX or even AL as the target thing. So, but this is going to be a separate thing. For now, I think it's good enough. So with that, thank you very much for watching and see you next time.